Section 4.2, mean expected value and standard deviation. So this problem I want to do is look at the definition of variance and talk a little bit about how to find the variance. And then I'm going to go into the problem, how to go about how to do that with a PDF. All right, so this one is the variance and standard deviation for a discrete random variable. So in other words, this PDF is strictly for X, that is for discrete data. So here in the description, if we look at this notation, here is looking at x sub 1, x sub 2. So those are descriptive of individual values in the sample of size n, and it could be for a population as well because those are both closed sets. So what traditionally in the formula here for sigma squared is that there's a little like subscript of I there. And as we go through them, X and then more specifically here, let me put this with a sigma notation. So there's supposed to be an I right here as well. Like I is equal to 1 up to n. And so traditionally what you would do is go through each I, and that's what the notation here says. So first off, you're going to start off with I is equal to 1 here. And then this becomes x sub 1, and this becomes x sub 1. And you go through and do all the order of operations here, meaning that you subtract the mean, second power, then times this probability. The next thing becomes 2, and then all these x sub i's become x sub 2. That's the second value in the sample. You go through the same thing again. And then you keep going 3, 4, and 5, all the way up to whatever the value n is, and then we stop. I have more of a table format to do that like I did with the mean, and we'll follow that format here as well. But a thing here to keep in mind that, again, this is the formula for the variance, that's sigma squared. And of course, as always, if you want to find the standard deviation, always take the square root of the variance as the last step. Here inside the parentheses is your parentheses, and that's what you want to do first. You want to subtract the mean. Then we're going to raise it to the second power, and the last step times its individual probability. And of course here, just to get a little reminder that the standard deviation is always the square root of the variance. So let's go ahead and pick up an example right now, and we're going to go ahead and do that. Find the mean, variance, and then standard deviation for a discrete random variable. Okay, here we are in our first example here in 4.2. Given a discrete random variable PDF here, we're going to use that to find first the mean, variance, and then standard deviation, this type of problem. Here it says a hospital researcher is interested in the number of times the average post-op patient will ring the nurse during a 12-hour shift. For a random variable of 50 patients, the following information was obtained. So they're post-surgery here in this case, and some numbers were given based upon probabilities. This very well could be a conversion of what had happened over time, that there may be a frequency along with this and it originated into these probabilities later. So nonetheless, we're going to take from this form as opposed to section 2.5 and use this again to find the mean, variance, and standard deviation. Here's always for the first step, what we're going to do is multiply across and then use that to find the mean. So you're going to take the value x and multiply to give us the following here. Like the first one, 0 times 0.8 is 0. 1 times 0.16 would be 0.16. 2 times 0.32, of course, is 0.64. Next, 3 times 0.28 is 0.84. Next here, 4 times 12 is 48. And last one, 5 times 4 is 20, or 0.20. So we've gone ahead and multiplied. Last step there is to add. So let's go ahead and do that. Let's take the total of all of those decimal values. Zero plus 0.16 plus 0.64 plus 0.84 plus 0.48 plus 0.20. Okay, that equals 2.32. Don't round that number. That's our expected number of rings. So we can expect in a 12-hour shift, and that's typically for nurses, they can, well, that's a different topic though, but 2.32 rings is expected in a 12-hour shift. I get a lot of nursing students, so that's why this is a great problem to use. So that's the mean. Again, don't round that value. We wouldn't expect to round it because we want to try to avoid rounding at all costs until we get to our very last answer, and we'll address that in a little bit. Realize that when I'm going back to the rules of rounding, I'm addressing that first rule, that first paragraph there, more specifically the first sentence there, talking about rounding to one more place than our data. And so realize that our data is discrete here. The number of rings is our data. Either the number of rings was 0, 1, 2, 3, or 5. Again, that is discrete there. Those are strictly whole numbers. So therefore, I'm going to round my statistics later to one more place than that. I can later come back here and round the mean, variance, and standard deviation in another time. So let's go ahead and find the variance. Here's my table method of doing that. What we're going to do first is subtract the mean. I'm going to take the number of rings to subtract the mean here. That's our deviation. Don't pick up the PDF, or sorry, the PDX here. We're just going to blank this out for now and not use it. What I want to do is take the number of rings, which is x, and subtract the 2.32. All right, so let's grab a calculator and do that for like this first one. Actually, let me address this as well before I do that. When I'm done with that, then I'm going to highlight, let me highlight this, that in this first row, I'm going to complete that. Then I'm going to find the deviation, raise the second power, and then last times its probability. So we just want to be careful that we don't subtract the probability, but we want to subtract the mean. That's usually a common mistake, and we're going to try to prevent that. So let's grab here for 0. 0 minus, and it's easy if you do this in rows, 0 minus 2.32 is negative 2.32. We'll keep that answer there for a second. Now what we want to do is raise that to the second power. So I'm going to square it and write that number down. 5.3824. 5, again, 5 point, let me erase that, 3824. But then the last step is to multiply that number times its individual probability. We'll go ahead and do that last. Let me finish out my deviations and then square it. So take that answer and square it. Next one here for 1. 1 minus 2.32 is negative 1.32. And then next what we want to do is square it. So I'm going to raise that to the second power. 0.17424. Again, writing that whole number down. 1.7424. Okay, next with the number 2. 2 minus should be negative 0.32. So 2 minus 2.32, again, is negative 0.32. And let's go ahead and square that. And that becomes 0.1024. Okay, next one, 3 minus should be will be a positive number, 0.68, and then we're going to go ahead and square that. So again, let me take the calculator here, 3 minus 2.32, positive 0.68, square that, 0.4624. Okay, almost done here, and then we'll deal the probabilities last. 4 minus 2.32. $1.68, and then let's go ahead and square that. So 2.8224. Okay, last one here, 5 minus 2.32 is 2.68. And then raise that to the second power. 7.1824. Again, so here's 7.1824. Okay, now that that's done, what we're going to do is now figure what the last row, or sorry, last column there is with each one of these like deviations and raise the second power here. So now what we're going to do is uncover the probabilities. Let's get rid of that and go ahead and fill it here. So what I'm now going to do is going to grab my first one, my first deviation squared times that probability. We want to multiply those together to get our answer. And then I'm going to kind of move that down here to find the rest of these. So let me grab a calculator. Let's do that for the first one. 0.08 times 5.3824. And that gives us, write this whole number down, 0.430592. Okay, that one's done. Next one, what we want to do is move this. So I'm going to move this concept down. See if I can grab all this for our next row here, almost. So this one, we want to end up multiplying the 0.16 times 1.7424 to get that last column. So let's grab a calculator and do that. Again here, 0.16 times 1.7424 is 0.278784. Okay, done. 4 more of these to go. The next, we've got, I'm going to multiply that times that 0.32 times the point, grab it here, the 0.1024. Okay, so that gives us this number, 0.032768. Okay, and then halfway there, let's keep going. Next one here, we're going to take the 0.28 times the 0.4624. Equals 0.129472. Okay, the last two is pretty much that same procedure. Now for this next one, I'm going to take the 0.12, the probability times that squared value. And then this one, I'm going to just write those answers down there. I think you kind of get the idea. This next one's going to be 0.33888. And for this last one, that product is going to be the 0.04 times the 7.1824 is 0.287296. And then what you finally want to do here is add up this column. That's going to be, that total down here is going to be our answer. So by adding those together, we get a grand total of 1.4976 rings. So this will be equal to our variance. And the last step, what we want to do is square root that to find the standard deviation. Again, don't round that value. I know it's tempting to go ahead and want to round it, but this is equal to, this is going to be our sigma. So sigma is equal to this quantity. Let's go and grab a calculator and do that. Let's take the square root again of the 1.4976. Okay, so that number there, that's going to be our answer, the 1.22. Then we can finally round that one. So that's equal to, so that's the square root again of our 1.4976. And of course, that's equal to 1.223764, rings. And then finally, we can round that to one decimal place because we have whole numbers for our data. So then I can say for that statistic that sigma is then equal to, or approximately equal to, 1.2 rings. And vice versa for the others, I can go back and go ahead around that I can say that my variance is approximately 1.5 rings. So you don't want to make the mistake of taking the square root of a rounded value. So I've got my sigma squared, the variance sigma, the standard deviation, then finally can go back to here, the 2.32, and again round that, that's my mu. So mu could be approximately equal to 2.3 rings. And so I bring this up when rounding your statistic, you want to round it at the very, very end.